One of the really useful features of LineSmarts is the ability to measure structures and supports in a span. So if we look at this example here, we can go into this measurement. It's just a regular LineSmarts measurement of the span. What you can do is you can select from here support measurement. And what you can see in this example here is we've already got measured the height of two poles. So if we look through the results, you can see there's results for the left and the right pole. And the left pole is about 8.8 meters high and the right pole is 8.5 meters high. There's other results here. There's also, you've got this vertical length, which is roughly pretty much your vertical height, and your horizontal length. If the pole was straight up and down, then you'd have no horizontal length. And then there's lean. Notably, if you look at the bottom here, the right pole has about 5 degrees of lean, and if we look in the image, we can see that is the case. However, it's not just pole heights that you can measure. If we click in here, we can go for this left pole, and the way you select your pole is you've got these buttons up the top here. So if we select that left one, and we can measure the diameter of this pole. It's just by placing these crosshairs into on either side of the pole. So we can select the different crosshairs using this A and B button. And we go back, and the diameter of that pole is 320 mil. So we could be measuring the diameter anywhere up the pole. So another thing we can do is, well, you can obviously select the height at any point. You can have the diameter at any point. We could also choose to try, for example, and measure the dimension of this crossarm. So if we very carefully put the crosshair there and up here, not quite exact, but if you took care, you could do it. It's about 100 mil in height and around about 70 mil in width. So that'll be 100 by 75 crossarm. It's good enough for sizing, determining what size crossarm you've got. It's not just that you can do though. If you get yourself at right angles to the pole, you can also measure the crossarm length. So in this example, we've got that, and if we go to support measurement, and we can see that what we've got there is the two crossarms have been measured, and in both cases are around about 2.7 meters in length. Now, again, because we're at right angles, it means that we can measure anything that's in that plane. So if we look at that structure which is in front, which is the right pole, and zoom in here, as an example, we could measure this crossarm brace. So again, we've got the point A selected, and then go for point B. And we go back, and we'll see for the right pole, that length is around about 900 mil, 880 mil. And if you did it precisely, you'd get a precise result. You could measure all sorts of things. Looking in there, we could be measuring distance between phases, distance between the circuits, and heights above ground and so forth. It's not just distribution assets that you can measure though. So if we look at this example here, you can see there's a transmission line, and if we go to support measurement, we can zoom in on here and we can see that we've measured an insulator. And sometimes these lines, when a measurement's already been completed, the lines can obscure your view of what you've measured. The button on the top right hand here allows you to make those lines appear and disappear so you can see what's behind them. Now if we go back, we can see that that's around about 2.3 meters, that insulator. And so to show that this will work in other places, if we click in here, should be able to go up to the top here and get a measurement up here as well. And that should also be around about 2.3 meters. It's a bit approximate, but 2.2 meters. So with a bit more time, you could get it precise and you'd have that right as well. So another example of a transmission line structure here, if we go into support measurement, and the cross arm has been measured, it's 10 meters, and so equally we could go in here and we could for example, we could measure the length of this brace. And so that's 3.2 meters. And of course you can get the height of the tower and any dimension you'd like really that's at right angles to the observer.